So yeah, I'm Phil Graeve. I work for the Prescribed Fire Training Center. I've been there for a couple years. Just real briefly for those who aren't familiar, it's an interagency training center. So a lot of people are mistakenly thinking that it's just for federal employees, but it's truly open to anyone. So experiential training and the application of the learning principles that we're all trying to achieve are the objectives of the training center. So less NWCG classes and more in the field experience to build competencies. So that's my plug for PFTC. I can gladly talk for hours about it if you want to hit me up, give me a call, send me an email. But today I'm going to talk about a previous life when I was a fuel specialist for 5 years on the Payette National Forest. And, Meg asked me to talk about LANDFIRE use that the use of LANDFIRE data in that role. So I'm going to talk about two roles that I had when I was on the Payette, and that was as a fuel specialist and as a burn boss. So that give you a little framing for what we're talking about. So as a fuel specialist, we did planning. That's NEPA, National Environmental Protection Act planning, environmental compliance reviews type things. And so that was the fuel specialist hat that I wore. But then when it came to implementation of prescribed fire or thinning projects, it was more about being a burn boss, writing a burn plan and implementing that plan, writing non-commercial thinning contracts and inspecting and implementing those understory small diameter ladder fuel thinning projects. And so I'll talk about those two things, and then I'll probably try to wrap it up with kind of okay, now what? How do we do a better job of getting maybe feedback mechanisms from those implementers and from those planners for the use of LANDFIRE data? I kind of have to lead with some of my insecurities on this. I'm no longer a fuel specialist. I don't use these products. This might be 2 years out of date. I also was more of an end user of LANDFIRE data through a user interface. So I'm a little ignorant about what LANDFIRE data really is. I was just a user. And so just keep that in mind. That's the lens that I bring to the table. And so if I'm saying something that's mistaken or needs tweaking, just politely course correct me. There's no ego on that. So as a fuel specialist on the pay, I was asked with writing the fuels and fire draft reports for environmental compliance. So site specific, the plans. So NEPA, for those who don't know, there's two fundamental things that we're trying to accomplish by law, and that is inform the public of what we're doing and analyze the effects of what we're doing. Now, it's a great law, kind of. In my opinion, the implementation is a challenge of that law, but it's a great law because I think everyone can agree that informing the public of our actions and analyzing the effect of our actions, and that is what it is at its basic level. Those are very important things. So I'm writing a fire fuels EA analysis, a specialist report, we call it. And these are the metrics that I'm using to determine the effects and to disclose those effects to the public. So I'm using things like fire behavior and fire regime condition class to describe the effects of our proposed action, which was prescribed fire and thinning. Some of the information sources, you can see the LANDFIRE data, but I'm using it through the IFTDSS, the Interagency Fuels Treatment Decision Support System. So that's where most of my experience is. That's the user interface that I use the LANDFIRE data through. But I was also using local knowledge, silvicultural reports, and the forest disturbance history that every time there's a logging operation, thinning operation, or prescribed fire or a wildfire that's being tracked by the Forest Service tracking mechanisms called FACS, Forest Activity Tracking System. And some products that we created, it's kind of a little hard to see, but essentially we're looking at the no action. We're not going to do anything out there. Thin and prescribed fire and prescribed fire. And really what I was trying to show using LANDFIRE data is we have things like the vegetation departure data set. We have the fire regime condition class. We have fuel models, slope aspect. We have all of this raw data in LANDFIRE. If we implement these actions, what will be the impact on those variables? What will change in flame length and rate of spread, these fire behavior products if we thin and burn, or if we just thin, or if we just have a commercial timber operation. Those were the things that I was trying to quantify. So a lot of these they feel abstract to the public or to an uneducated stakeholder, uneducated in forestry and fire management. And so trying to take an abstract fire regime condition class can be an abstract thing to wrap your head around. Trying to quantify that was kind of the challenge that I was trying to address here. And some of the overall results of the modeling that I was doing is reductions in flame lengths. Rate of spread kind of changed because timber and grass behave very differently. And if you're transitioning from one to the other based on your proposed actions, it kind of skews the results. And so there's some implementation, there's some interpretation that has to happen too. It's not just about the numbers. But really, one of the best things that we saw from the proposed action was changes from an active crown fire. Basically, if there's too many trees, it's too dense, there's too many ladder fuels, there's going to be more crown fire. If you reduce those through this proposed action, you're going to have passive fire, which is more independent tree torching. That's actually desirable. So we're able to control that fire, and it's behaving more ecologically appropriate. And so this is a kind of a little bit of complicated one. You probably won't have a chance to really tease out the nuance here, but essentially it's showing the only thing that really proved to have consistent reduction in these rate of spreads and flame lengths and intensity was thinning and burning. And that jives with the fire surrogate studies that we've seen over the years too. So with NCT is non-commercial thinning, with just that, you're putting more fuel down on the ground and you're increasing the fire behavior in the short term, but in the long term, it's desirable. But true across the board reductions that were desirable were all of the treatments after all of the treatments were accomplished. Hey, Meg, this is probably a good time to just mention I'm not tracking the chat very well. So if there are questions, just jump in, please. Happy to pause. So that I went really quickly through the fuel specialist environmental compliance part of my job. And now I'm going to talk about the prescribed fire implementation and burn plan writing part of the job. The reason I'm going to go in with those two categories is used LANDFIRE data very differently, but IFTDSS and fire behavior modeling were the user interfaces that I used to analyze that data. So it's planning, 2 to 10 year kind of outlook of what we're going to do, and then there's the tactical, and so that's strategic, and then there's the tactical, like, okay, now we're going to go burn, and this is the plan, right? And so just as a quick reminder for those who aren't involved in burn plan implementation, we're trying to do 3 things. We want to achieve objectives that could be like fuels reduction or maintaining restoring ecological processes. We want to manage the smoke because public health is very important to everyone. We don't want smoke in communities if possible. Not always possible, but that's the goal. And then we want to keep it in the box. That should be pretty intuitive. We want to keep it, the box being the planned area of burning for that day. We want to keep it within the unit. So I used IFTDSS, that Interagency Fuels Treatment Decision Support System, because we love our acronyms. That was the user interface that analyzed the LANDFIRE data for me, created a landscape summary report, and it has static environmental things like fuel model, canopy base height, canopy cover, density, a bunch of other metrics. I just grabbed a couple. I say static, they do change over time, but they're pretty slow to respond unless there's actions implemented. And then, so that's the landscape summary report. And then the landscape fire behavior report are those metrics like flame length, rate of spread of the fire. That's usually measured in feet per second or chains per hour, feet per minute or chains per hour. I'm using industry terminology. It doesn't really matter. It's how fast is the fire moving. Intensity is how hot it is, measured in BTUs. And then crown fire initiation. So that was also important because that's a key indicator of whether or not under a wildfire scenario, we will be able to suppress that fire, catch that fire under prescribed fire conditions, whether or not that's going to be the ecologically appropriate. Like that's kind of a good indicator of the fire regime condition as well. So there's a lot of interpretation going into some of this. And there's a lot of interactions between variables and processes. I'm going very high level and very quickly through it all, but I'm happy to dig in if y'all want to go back to any of these. And so these are some of the products that we created. It's a fancy map, and I'll try to interpret it for you. But one thing that IFTDSS can do for us is it can take that LANDFIRE data and it can interpret it for us in a spatial manner. And so this is important to us because if you look on the north end of this prescribed fire unit, this is about 5,000 acres. You can see that hopefully you can intuitively see, knowing nothing about fire, you can tell that there are weak points on our holding lines. The purple is the holding line. We want to keep it in the box. If the flame lengths are highest on the north and the east side, that is an indicator that we want to address. If the intensity is the highest on the north side, as you're seeing in the third from the left, and if the crown fire, you're starting to see a pattern that the north end is a challenge in terms of some of these metrics, some of these parameters that we're looking at. And so how does that change the implementation? That's kind of the puzzle you have to solve from a prescribed fire standpoint. Now, I can tell you from local ground pounding experience, so you have to interpret it. You have to go out in the field and look at it. The north end is more Douglas fir as compared to grasslands and ponderosa and the other parts of the unit. So, but that tells me something about how we can implement it using fuel moisture transitions and our tactics, our firing patterns. We can manage that, but that's good to know, and that's good to ground verify, and that's helpful. That helps us interpret as subject matter experts. We can interpret how we want to plan the unit, how we want to build the firing plan, and how we want to keep that in the box in that confined area. And so the LANDFIRE interpreted through IFTDSS provides those products. One cool thing about this is in the past, when I started my career, we had behave, and that was tabular, and that is very important. That helps us understand the data. This provides that spatial component, and that is also helpful, as you can see with looking at the north. The north holding line is the area of biggest concern. But it still needs that interpretation. It still needs context. It still needs ground truthing. So anyway, I went through that really quickly. I talked about the fuel specialist role and the prescribed fire burn boss role, the planning of the implementation. I'm going to pivot and just kind of move towards like how can we do a better job, or how can we better integrate the implementers and the producers of the data, the maintainers of the LANDFIRE data, and the user interfaces that we use? How can we build better tools? So I was talking to Meg and a couple other people from LANDFIRE about this, but I talked to some fuel specialists in the area that I still know and work with, and the feedback they had was in central Idaho, the fuel models show as shrub, but that's not indicative of fire behavior for the most part, especially during these prescribed fire shoulder seasons. It's actually more of a timber understory or grass model. And so, like, I guess the question here is, how do we provide that feedback? How do we provide this feedback mechanism between the people using the data and the people producing and maintaining the data? Another thing that we see in this part of the world is, and I just saw this on a wildfire a month ago, is like below 4,000 or 5,000 feet in elevation, sage is an incredible challenge for suppressing fires. It'll move very quickly. It's hard to control without aviation and dozers. But it has a transition point of about 5,000 feet where I've never seen it burn. Above maybe 6,000 feet in elevation, it doesn't burn. So it's an incredible safety zone, a holding feature. But I still see people putting line through high elevation sage, thinking that they're going to catch the fire when the fire won't burn through there. So it's not just a data problem; it's a mindset problem too. That's for another conversation. But I guess the key thing here I'm trying to get at is, so upper elevation sage will probably never burn except in Armageddon fire years, and even then, I've still not seen it. How do we account for in valley bottoms with grasslands with flood irrigation and pivot irrigation? That will never burn because it's watered every week. How do we account for that in the data? And really, the last bullet I have right here is How do we make it easier for people to make those changes on the fly in their interpretation, in their analysis? How can it be done in the field? How can it be done without spending a half a day learning how to program things in the computer or tweak the models? Like there, I think if in a perfect world we would move towards a way where we have good tools for wintertime planning. How do we build better tools for week of or day of planning? And you can see that that ties into my next statement. IFTDSS, which is that user interface, that program that we use, it keeps people at the office, but we want people in the field. We want people walking through the woods and snapping sticks to see what the fuel moistures are and sampling fuel moistures. That's where we want to be. How do we build a tool that can help us do that? And this is kind of what I came up with again after talking to folks in the area and friends around the country who are fuel specialists and burn bosses. And this is something that ties into what Russ is going to talk about really elegantly, I think. So teeing it up for you, Russ. It would be good, and I know I'm talking to a LANDFIRE crowd, but the user interface is the connective tissue between data producers and maintainers and users. I think perfect world scenario would be that we would have something on a phone or a tablet that worked in the woods with cell service or satellite service, where I could run fire behavior analyses based on the current weather for that day, like in a gridded weather forecast. I could change firing plans based on that changing weather. I could use the LANDFIRE products and data like aspect, topography, fuel models. I could edit those fuel models and I could do it all in 5 minutes, not hours. I think that's maybe a dream, right? And I'm not sure if this is the audience to bring that to, but I figured why not try? Why not inspire some discussion? You never know. Maybe the problem is in the user interface or the challenges, but maybe the data that it's using and interpreting can be tweaked to make it easier. So here's some direct feedback I got from some friends and colleagues around the country. LANDFIRE is not super helpful, but when integrated into user interface like IFTDSS and WIFTDS, it can be helpful. WIFTDS is the wildland fire decision support system that we use for unplanned fires, wildfires. Recommendations were improvements to the user interface. Like I just said, sometimes the user interface needs the tweaking. Sometimes the raw data needs the tweaking. Sometimes you have to go back to first principles in order to make those changes. So that's why I bring it up here. I added this based on some conversations, more user defined, choose your own adventure. Like I said earlier, how do you take it? How do you put it in an app that can be, how can you change those fuel models and live fuel moistures and weather parameters in the field on a phone in 5 minutes and get a new product? How can you change the firing plan because the wind's changed in the field and get a different output from the model? Um, and yeah, it doesn't reflect all the fuels appropriately. I kind of use the example of shrubs and high elevation sage. But basically, another way of asking this and simplifying is how do we reduce the friction to make those changes in the field? That's kind of I've said that in a couple of different ways, but come back to that in a little cleaner, concise way. Anyway, those are kind of the quick rundown of how I use this and some feedback from the field, maybe some suggestions. I think at this point, Meg, we can offer it up to questions or discussion. We can send it over to Russ and come back to the conversation at a later time. I did want to put in one quick plug. We have a developing burn plan workshop that's offered in December. Application is out right now. And that is intended for bringing together all of the audiences, all the data folk, the burn plan writers, the implementers, anyone who has a vested interest in prescribed fire implementation is welcome, right? It's focused on the burn plan as it's written, but it's also focused on the plan. Like this is our plan to go burn. So like one is a proper noun and the other is a verb. And there has to be connection between the two, right? So this workshop is kind of intended to bring all of the stakeholders, discuss the parameters of the plan, build relationships, increase the communication between the different stakeholders. Anyway, check it out if you're interested. If not, I'll tee up Mr. Parsons here. And that's the end of my.
Yeah, I just want to make sure that folks are aware of our seasonal fuels product, which comes out 4 times a year and adjusts for some of the greenness that we're seeing throughout the season. And so it will adjust some of the fuel models with that NDVI from current satellite imagery. But I don't think it's pulled into IFTDSS, if I'm remembering correctly.
That's correct, Inga. Not
Okay.
yet.
But I think it might be in, is it in WIFDIS? It might be in WIFDIS.
Yeah, I think WFDS does serve that data.
Okay. So yeah, so there is, some aspect of trying to capture at least fill like the green, the areas that are constantly being watered and have really high fuel moisture versus those areas that, green up and then kind of senesce, get cured. So hopefully, but again, that's only in the Southwest. So whether it covers your region or not, that kind of changes throughout the season, how much is covered. And I'll put a link for that as well.
All right. Hey, very much appreciate getting to be part of this. This is my first LANDFIRE Office Hour also. Very exciting. And thanks to Phil for inviting me to come today. So before I get going, I just want to mention that I'm just part of a big team here. And as you can see from my list of partners, which is actually not nearly all of them, I've got a lot of people that I work with who are doing amazing work, and I'm really grateful for all their work. I also just want to express my appreciation and gratitude for all the time I've spent talking with the IFTDIS team, the LANDFIRE team, the WIFDIS team. I say, if you're not with us, you're against us. And anyway, they've put up with me and my chattering for a long time. So appreciate the opportunity to be here and really appreciate their partnership. Okay, so I appreciate the lead off from Phil. I think he walked us through some, examples of how people are using data from LANDFIRE in applications like IFTDIS, and the kind of, had some great ideas on how we can update that kind of stuff and make that more fluid. And I hope that what I'm talking about here will help in that direction as well. So I'm going to be talking about FastFuels, which is the 3D fuel modeling platform that I lead that project, and then its connection to a number of other tools that I think help us expand the toolbox for fire management, particularly for prescribed fire and fuel treatments work. So let me jump in here. So this is just preaching to the choir, but I always feel like I have to have a slide like this in there, right? So obviously the wildfires get our attention and they're kind of what the public thinks of with fire, but we know that we can't suppress our way out of the fuels problem. We have to be proactive. And so with wildfires, you think about that fire behavior triangle, all three sides of that are kind of beyond your control. You're being dealt a hand and it might not be good, right? But with prescribed fire, basically, you can treat the fuels beforehand. You can choose the weather window in which you burn, and you can use topography to your advantage in your ignition. So you basically make all of those liabilities an asset. And you can really see this from this picture. So the picture in the background is the bootleg fire from 2021. And this is an area where we were doing some prescribed burning with the Nature Conservancy at the Sycan Marsh Preserve. And on the left side, you can see where we had burned in 2019. The big fire came rolling through and, burned up, the first trees on the edge and then dropped to the ground. And really, we had minor fire effects in there. Whereas across the street, there was some commercial timberland that had not been treated with prescribed fire. and it had like 100% mortality. So for me, I really see this as fuels are the solution space for the fire problem. They're the place that we can be proactive the most, and we can plan ahead and think about where we're going. And data from LANDFIRE, tools like IFTDSS, and some of the stuff I'm going to show you today, I think really helps us get there. So I'm going to kind of go over a bunch of this pretty quick because I'm mostly looking forward to just kind of running you through it and then having time for some questions. But the idea is that there's a lot of new things coming up in fire science, new fire models, new tools, and I think it gives us an opportunity to explore these kind of things that we want to do in more detail. So if you think about it right now, there's obviously just a tremendous number of data products that come from LANDFIRE that are used in thousands of applications. And you think about it, if you're a master's student right now in natural resources, chances are really good you're going to use LANDFIRE data in your project, no matter what it is, right? And of course, there's this whole host of applications that are used in fire management that use that data directly. And Phil was just walking us through some of that. So we've got WIFDIS, IFTDIS, RMA, WIFDIS Next Gen, the FlamMap desktop tool. Then you have some additional things like ARC Fuels, Land Tender, Wildfire Analyst, and Plantscape. All of those are using them. In fact, there's way more than that, right? It's a fundamental data source and platform for everything going on in our country. Like it's used even far outside of fire, right? So several years ago, one of our partners here at the Fire Lab, Karen Riley, developed TreeMap. So what that does is it takes the FIA data and it links to FIA tree lists and does this imputation of likely matches for, in a broad sense on the landscape for where there's forest and what those forest characteristics might look like. So it's producing this platform that delivers not really site specific, but defensible tree lists associated with places on the ground. So we use that as kind of we took that entry point and we built FastFuels. And so we're taking in our basic form, we're taking the data from TreeMap as well as the surface fuels from LANDFIRE, and we're building 3D fuel maps. And we're building off some stuff we had done in previous work with a JFSP funded project called StandFire. So I don't know if you ever heard of that, but it was a desktop application that started testing some of these things where we would go from tree list data without coordinates, which is what we get from TreeMap, into modeling it in 3D and using it in those kind of applications. So anyway, TreeMap or FastFuels is building off LANDFIRE data, and we're trying to add value to it. So once we build these 3D fuel maps and data, we can support a whole bunch of things. And today I'm going to walk you through all of these things, or well, most of them. So first of all, it gives us access to input data for multiple 3D fire models, including QUIC-Fire, the Fire Dynamics Simulator, FireTech, and QES-Fire. These are all dynamic 3D fire models. And our goal with FastFuels is to be model agnostic in that we want to support all fire models. Then I'll be showing you this DripTorch tool. And you've heard of FDS. I won't be showing it today, but with the tree list that we're developing here, we can run that. We can also use FireVista, which is a VR platform that enables us to put people in the driver's seat and see what's going on in their burn. And then there's two integrative platforms that link these things together that I'll talk about briefly. One is called Burn Pro 3D, developed by our partners at UC San Diego. And the other is the Los Alamos National Lab QUIC-Fire GUI tool. So basically, all those things are expanding the toolbox. We're not trying to get rid of any of the old data or old products. We're just trying to add more tools and data. So the other thing that we see is, and one of the things that we can do with that is, when we started FastFuels, we were just dealing with the TreeMap data as the input. But now we have what we call Onramps. So we talk about FastFuels as a superhighway connecting fuels data to fire models. And Onramps are data assimilation platforms that enable us to bring in data exactly like what Phil was talking about for your local site, faster, easier. And we include Onramps for drones and things like that. And so those are in the works. And I'll show you some examples of the other Onramps. And I think you'll see that this is very helpful for getting local fuels data for your particular project. So with all of that, what we really want to do is, particularly consistent with our idea of supporting all the fire models, we want to be able to feed back. We want to be able to feed back to these applications, and we also want to be able to feed back to LANDFIRE. And I'll walk you more a little bit through that as we go along. So I'm going to just go through pretty quickly some of these tools that we're kind of bringing to the picture here. So FastFuels is the fuels platform. QUIC-Fire is the main 3D fire model that we're working with right now. DripTorch is a platform for developing spatiotemporal ignition patterns for prescribed burns or for looking at particular cases for wildfires. BurnPro 3D is a integrated platform that links all three of those. And the same thing is true for the LANL GUI tool. And then FireVista is on the far end of that. And it is a viewer program that enables us to put all that data into VR. And I should mention also, there's an additional downstream model from QUIC-Fire that is called QUIC-Smoke that takes the 3D plume data from QUIC-Fire and looks at the concentrations of that smoke, et cetera, downstream. So you can look at smoke impacts to communities and things like that. So just briefly, this is kind of looking at FastFuels. Our data is 3D. Instead of pixels, we have voxels. Some people like to call them voxels. And within a given tree crown, we model occupancy. And we have a model that basically distributes the fuel towards the top and outer edge of the tree, but offers some voids within the tree crown. And the goals with FastFuels are to expand the toolbox for prescribed fire and fuel treatments. It's a data on demand system. So it basically, similar to when you go into IFTDSS and you draw a box for your area, in that case, it's pulling data from LANDFIRE. In our case, it is developing it right then from the inputs that it needs, which include data from LANDFIRE, particularly for surface fuels at present. So this data on demand window is available in the whole lower 48 states. We think of it as a super highway for fuels to fire models. So the idea is to accelerate this pathway for the best possible fuels data for any location. And then here's the paper that just came out earlier this year, if you want to check it out. And the link up here also will get you there. So here's QUIC-Fire, which is a model developed by Los Alamos National Lab, and also with scientists from the Forest Service Southern Research Station, including Scott Goodrick. And here is an example simulation for a site where the data was brought in using LiDAR data and terrestrial LiDAR. You can see it's a 3D fuels map, 3D scene. And what you're seeing there is an ignition pattern that included both drone and I think it was a 4x running on the outside edge. Okay, so that illustrates the kind of fine grain of both the ignition, the fuels, the topography. And then another thing to notice is that this model also captures the plume in 3D and interactions like fire on fire interactions. So this is an important tool for looking at some of the more nuanced behavior of fire behavior models. So let me keep going here. DripTorch is a tool that we developed that you can set up an ignition over time and space within your given unit. You can, using the interface like we have here, this is an older version here, but basically you can set like how many igniters, where are they going to start? What kind of pattern are you using? In this case, we're using a strip head fire. And then the tool will actually show you that as an animation. So you can see what that's like, and then it'll tell you how long that'll take. If you change the number of igniters or the spacing between them, it'll recalculate it. So it's a really useful tool for understanding and communicating those complex patterns. BurnPro 3D is an integrative platform. It's browser-based. It was developed by our partners at UC San Diego with NSF funding. And this is the back end. So basically, it takes... it combines FastFuels, DripTorch, and QUIC-Fire, and then it has this really cool back-end analytics. And here I just want to spend a second talking about this. So in this case, we did an ensemble, just like you're used to using Behave Plus, where you put commas between different wind speed values or fuel moistures, et cetera. okay? With Burn Pro 3D, you can do that, but instead of a point functional calculation, each element is a full 3D fire simulation. And so in this case, we did 9 simulations in this case, spanning a different range of things. And we set some objectives on what we wanted in terms of fuel consumption by different strata. And you can see that ones that met our criteria show up as green, ones that underconsumed are blue, ones that overconsumed are red. And this is a live filter. So right now, the only ones that show up are the ones that met those criteria, those 3 cases, and they're shown here. And if you were to go down in the thing, this would give you some output. And then you could click on these and show an animation or see the endpoint state of the 3D fuels that were on there. So then this is a similar integrative platform, but it's not a browser-based tool. It is a desktop tool. And here's an example unit here in Montana that's being planned for being burned this fall. It's a 12-acre unit, and it was treated. And so if you go through this tool, which was developed by Los Alamos National Lab, this is the view of the fuels. You can see there's a road at the top that's the control line, and the unit is kind of that triangle. And then this thing has a built-in 3D viewer, so if you can, move it around with your mouse and look through the scene. And then you can get the output, and then you can take the output and dump it into FireVista. So this is another 3D thing, but it's VR, and this is with our partners at FireVista. And this is also very interactive and in the VR. And here you can see just that, just changing the perspective, you can see the plume is also 3D. The fire is 3D. You can see these like piled up boxes of fire. So this is a really powerful tool for visualizing this output from these models. So here's an example of what that looks like if you're in the VR. In this case, you're standing above the whole unit like it's like a virtual sand table, and you are looking down at it. Where we're headed with this, it's going to be multiplayer, and you could imagine using it for briefings. So imagine that you're putting a prescribed fire together, maybe say next week or in a few days. You would use this system to run a few cases with different winds, different fuels, whatever, different ignition pattern. And then you would be able to see them together and talk about what you're looking at and see how it turned out with respect to your objectives. So another application of this kind of tool suite is to really go under the hood with your fuels treatment. So this is an example in which we used this kind of platform to run fire simulations with another fire model that's called the Fire Dynamics Simulator. And here you can see the pattern of fire moving under the trees with different structures, and how those structures change the wind field. And we can do all sorts of different treatments because FastFuels is 3D spatial explicit and deals with treeless data. We can simulate silvicultural treatments to any level of detail you want, and we can also simulate clumpy spacey, clumpy groupy, things like that. Here's the paper that just came out recently that describes some of that work, if you want to check it out. And then this is where we're coming back to where we think this could really be useful, not only to expanding the toolbox for managers for prescribed fire and fuel treatments, but also to LANDFIRE itself. And that's through what we call these Onramps. So the idea is that it's a data on demand system. And in its initial formulation, it relies on the tree map data to provide these tree lists that were built on an imputation that uses LANDFIRE data as inputs. But if you have other data like high resolution imagery or LiDAR, the idea is that you can use the Onramps to update the data in your site. So basically taking advantage of multiple sources of remote sensing and put things together. So here's another paper that we had recently where we used some satellite high resolution panchromatic imagery to develop canopy height models, which can then be used as an on-ramp to FastFuels. Okay, so you can check out that paper. This is an example with our partnership with the Confederated Salish and Kootenai tribes here in Montana. We're doing co-production with them. We're testing a lot of these models with them on real-world burn units and fuel treatments. And this is a unit that they burned in 2023, and you can see the imagery of it. This is what it looks like when we use our ALS Onramp to bring the data into FastFuels. You can see the individual trees are comprised of multiple voxels. Each voxel has a series of attributes that carry the data that are needed for the 3D fire models. And then we can take that and you'll notice also that there's variability in the surface fuels here. That's an output from another model, which is called Duet, where we could take the FastFuels data and dump it into Duet, and then we can give it some time since fire kind of parameters, and it'll simulate the accumulation of fuel on like litter under the trees and growth of grass under the in open areas. So this is what that looks like when you look at it with QUIC-Fire. In this case, we use the DripTorch tool to put a bunch of igniters moving back and forth across the unit. You'll notice also we're getting some escapes outside the unit here. And, in the real world, we probably call these guys and say, hey, hold up, we have some spots. But it turns out that these are not real people. They're just little computer things. And so they don't know. They are dumb. They are stupid. Okay. But you can imagine that being able to run a simulation at the scale of your particular burn with a particular ignition pattern and fuel moisture and wind, et cetera, and then seeing where it does escape, and then doing that over an ensemble of such things could give you some insights about potential problem areas or things you might consider. Okay, so the whole idea here with these on-ramps is that it basically enables you to automate the fuels map updating. Okay, so if you have an area that you have data for example, you can just basically find that data, bring it in, and update your data. Okay, so for all those forests that have invested in LiDAR data, this process could be used to update their LANDFIRE maps for their sites. And one of the things that really becomes powerful here is this is automated. So if you think about that data on demand window and then moving over time and just cycling through the landscape and looking for what data is out there and bringing it in, you basically get this capacity to accelerate the LANDFIRE refresh cycle. So you could have it essentially accumulating new and updated data and then have periodic refreshes to the whole system, or however you want to do it. Like, again, it's about providing the best data for your local site. And we're doing the on-ramps as a matter of course when you pull in the data for your site anyway. And there's going to be more and more on-ramps going forward. So again, this was just intended to kind of give you a preview of some of this stuff. What we're really excited about is working with folks like we're doing with the Confederated Salish and Kootenai tribes, and doing this kind of co-development where we're testing these platforms, testing the tools. We think that there's a lot of applications here for getting under the hood on fuel treatments, prescribed fire planning, and then particularly with that VR thing, we think it could really change how we do firefighter training, just making it more immersive and interactive. And then we also think that there's a lot of applications here that are in the kind of finer scale of risk assessment. So like we won't be using these models on the huge scales that they use FSIM and whatnot to guide large scale regional risk assessments. But if you think about a particular unit and the particular configuration of fuels that are out there and what risks those might pose for you as you're putting together your burn plan, we think that could be useful. So that's it. And then I'm just going to close here with a video that shows some of our drone work. This was with the Nature Conservancy out at their Sycan Marsh Preserve. We did a bunch of prescribed burns with them from 2017 till recently. Hope to get back again there soon. And just for me, this is kind of the glue. So on top of the modeling, to collect data on real burns and use it to evaluate the models and help us inform, how things might go, is really powerful. So, all right, that's it for me.
Thanks, Russ. We had a question from JT Parsons. Are any of these live satellite data current weather for on-site planning and adjustment?
So I can answer that, JT. So yes, with FastFuels, we have our on-ramps are picking up recent data. It's not necessarily from today, but let me go forward just one or two slides and show you another thing that we've got going on here. So we can connect to FVS. We can also this is kind of experimental, but we can take that data and we can start working at plant physiology-based fuel moisture. And in this case, we can then also simulate light through the forests and accumulate the carbon. So we're working towards plant physiology-based growth, but this might be of interest to you. So we've developed a handshake between a 3D weather model and FastFuels. And what this enables us to do is get ridiculously detailed 3D weather data in which the winds are wrapping around the trees and are influenced by the drag effects of the canopies. And this, as we're going forward with it, will have a forecasting capability that goes out a few days. And so you could get not only current, but also near-term forecasted weather, which we think would be very useful for a prescribed fire.
I was just personally trying to make a reference off of what Phil was kind of talking about. But that looks perfect. I mean, that's kind of, for on-site capability, but transplanting that to some sort of high-speed tablet.
Yeah. Well, that's one of the things we want to produce with this project is basically be able to tap into that kind of modeling and then make the data super available and super accessible.
Yeah, I'll just throw out there, maybe the idea of a phone or tablet in the field isn't there's an incredible amount of computation power behind some of these models. Like the nuclear laboratory at Los Alamos is powering some of them. So maybe it's not viable on a phone, but maybe you can work with someone at the office, input your parameters on the phone. They can send it to the Los Alamos computer and you could get the product, So there's ways to bridge the gaps, I think. But
yeah,
that would be a dream.
You could right now, you could hit the Burn Pro 3D from your phone, and then you could set up a simulation ensemble. But of course, the work's being done on their supercomputers there, so it's not having to be done on your phone.
Natalie asks, are the 3D fuel models still related to traditional 4013 fuel models, or is it all custom fuel models?
Well, so yes, that's a great question. Yeah, right now we are using the LANDFIRE Scott and Bergen 40 as our surface fuels, but we're also developing a whole series of different approaches to capture those fuels and those fuel dynamics with more detail. So we're going to continue to provide, we're going to continue to use that from LANDFIRE. And then as time goes on and those methods for getting better surface fuels data are more fleshed out, we might be providing some of that data back to LANDFIRE.
Yeah, Russ, I just put a comment in the chat, but what I love about what you're doing is it's inclusive of everything, right? So it's like there's dozens of different data sources and models out there, but what you're building is meant to have on-ramps for anything, things that aren't even invented yet, right? Like that's
Right.
powerful. That's the one ring to rule them all concept, and I love it, to borrow a nerd phrase.
Oh, well, I love that you're nerding out with me, man. That's awesome. So where we're headed with this is that FastFuels is going to be an open source platform and different research teams can contribute their own on-ramps. So, there's just a proliferation of different data sources and ways to process that data right now. It's an explosion of innovation in this kind of stuff. Tessa, I'm seeing your chat there. Yes, you can reach out to those folks. They might have been busy, but they will set you up with a beta tester account. I can help you with that. If you want to reach out to me on email, I can see if I can apply a little pressure.
Yeah, no, this is so cool to see kind of how things have developed. But I just, I wanted to kind of throw the idea of next generation LANDFIRE into people's heads and just say that, the idea in terms of next generation LANDFIRE is to present basically like a digital twin, if you've heard that, for the, entire United States. And so it's almost like the entire United States is an on-ramp, right? So we're just constantly updating the data based on what's available through satellite and LiDAR. And so Russ is, kind of well on his way to creating a system that could, pull in data as you showed, where it moved across the landscape and was looking for more data. So that's exactly the kind of thing that we're thinking about in terms of down the road, being able to serve up this data consistently through time and reflect any new disturbances that happen, as well as regrowth. So, yeah, it's exciting.
Yeah, it's such a cool time to be working in this arena. And I think we really need to have that kind of capability where, we don't want to throw anything out from what we have that Landfire has, because it's so critical to so many things, right? But what we want to do is work together to have a process by which different partners can contribute to it. It can be kind of curated. Like if there's a data product coming in from some team, say my team or someone else's, there can be a place where that gets curated, evaluated against stuff, and then parked in a way that people can test and use it. And then as it accumulates, confidence, it can be added to the long-term record. But it's really critical in this kind of integration and value added concept that we don't break anything. We don't want to break any of the tools that people currently use. We just want to add data and add tools to the toolbox.